Electromagnetic induction. This describes the phenomenon that charges moving in a magnetic field create an electric field. This idea was discovered by Michael Faraday in 1831. One of his experiments showed that changing the magnetic field induces a current. He showed this by sliding a magnet in and out of a coil of wires, in which he noticed a change in the current running through the wire. Based on this observation, he stated that an electromagnetic force is induced in a closed loop if the magnetic flux in a loop changes. His law states that this value, the electromagnetic flux, is equal to the negative rate of change of the magnetic flux through the loop. So many objects used daily follow Faraday's principles. An example of this is an induction stovetop. But before we get into that, we need to look at a few principles. Okay, so every electric current has a magnetic field surrounding it. Alternating currents have fluctuating magnetic fields. Fluctuating magnetic fields cause currents to flow in conductors placed within them. So knowing this, we can say that the changing magnetic field associated with an alternating current induces a current in a second conductor placed in that field. And this is basically the way induction stovetop works. So coils located just beneath the stovetop carry an alternating current, creating a changing magnetic field. When iron-rich magnetic cookware or ferromagnetic cookware is placed in that field, it acts as a second conductor, and a current is induced on it. The current is converted to heat inside the cookware, which is basically used to cook the food. And it's also the reason why in some induction stovetop ads, people are able to touch the surface directly or place food directly without it burning, simply because food isn't a very good conductor.